All right. Welcome. Today we are looking at the first day of lesson 12.4. This one deals with angle measures. Tomorrow we're going to look at the next one, which is going to deal with, I believe it's side lengths, segment lengths. Okay. This one I can find the measure of arcs using given angles. We're going to start by looking at what we already know. Okay. We've worked with central angles. Remember, a central angle is an angle where the vertex is the center of the circle. And if we know the measure of that angle, like this one is 50, the intercepted arc, in other words, where the two segments or rays that form that angle intersect the circle, that arc measurement is the same. It's 50 degrees here, it's 50 degrees there. Okay. Yesterday we looked at the inscribed angle theorem. And when we were working with the inscribed angles, what we worked with was the fact that an inscribed angle, the vertex is on the circle, okay, and then the chords that form that angle, where they intercept the circle, that's the inscribed arc, and the measurement of the angle at the vertex is half of what the measurement of the arc is. That's an inscribed angle. Then we also looked at one where we had an angle formed by a tangent, like this tangent right here, and a chord, this chord right here. And that angle, in this case, it's 140 degrees. It's half the measure of the intercepted arc, okay? And the intercepted arc is just between those two chords, so it's this all the way around here, which is 280, and that's half of that, much like the inscribed angle one, okay? So today we are looking at the measure of an angle that's, this is one of the things we'll look at, the measure of an angle formed by two lines that intersect inside the circle. Okay, so I've got an angle that's, I've got two lines that are forming inside, that I can't even speak. I've got two angles that intersect inside the circle, okay, and here's what we know, okay. The measure of angle 1, which is this one, is going to be equal to 1/2 of x plus y. And x and y are the two intercepted arcs. Okay, so it's equal to half the sum of the measures of the intercepted arcs. Add them together, divide it in half. Okay, we also will know, or use today, the measure of an angle. Oh, back up a second. Okay, that was inside, and that means it's not central. You know, we're not looking at central angles, and it's not inscribed. Okay, should go without saying, but I'm going to say that. Okay. All right, moving on to this one. The measure of an angle formed by two lines that intersect outside of a circle. So outside of a circle. Okay, so the intersection is out here. It's not inside the circle. It's half the difference. In this case, it's subtraction of the two intercepted arcs. So instead of adding these two arcs, we're going to subtract them. The small one from the bigger one. Okay, take half of that, and it gives us the measure of the angle out here at that vertex. Okay, and it doesn't matter, how that works. If you got that point and you got them, like the top one up here, it's cutting through the circle in two places. This one I've got what looks to be a tangent and one that cuts through, and on the bottom one I've got what appears to be two tangents. It's still going to do the same thing. It's half the difference of the two intercepted arcs. So let's do some problems. Okay, on this first one, all right, find the value of each variable. I'm looking for the measure of that angle. Okay, it's formed by the intersection of these two lines, and so x is going to equal half of the sum of the two angles. So I just add those two together. 116 plus 70, that's like 186. Cut that in half and I get 93 degrees. Okay. Another way that you could do that is you could do it this way. X equals 116 plus 70 divided by 2. And you're going to get 93 degrees. Okay. First one. Second problem. Okay. This one I know the angle. I know one of the arcs. I'm looking for the other arc. Okay. But again, in between. Okay. What do you mean in between? Or I mean the intersection is inside, not in between. It's inside the circle. Now here's the part that's a little bit different. That 139 degrees is not like the other one. It's not within. It's not like the intercepted arcs around out here, right? So this one messes us up a little bit. All right. What we need an angle in here, okay, or an angle right there. Those will be the same. All right, and so here's what I know. This line is 180. Okay, so if I take 180 minus 139, which gives us 41 degrees, that's going to be the angle measurement right here. Okay, and so now I can do the piece where I'm looking at that angle being 41 equals, and I'm going to add the two intercepted arcs, x and 40, and dividing it by 2. Okay. I couldn't do it with the 139 because it's not the one with those two intercepted arcs. Now, I need to solve for x, so I'm going to multiply both sides by 2. Okay, and that gives me 82 equals x plus 40. And then I'm going to subtract 40 from both sides. And I get 42 degrees for x. Okay. Next one. I have an angle that's outside. Okay. Got the angle that's outside, and I've got intersected arc here. I've got intercepted arc out here. Okay. But notice I went a little bit too far. It goes to right there. Okay. It's the outside part out. We'll do that one in a different color. Okay. Let's try this again where it's easier to see. Okay. The first one, the 65 degrees, that's right there. Okay. The other arc, intercepted arc, is going to be this one. Okay. This line crosses the circle in two places. So this outer arc here is going to be, it intersects right there. And the other point of intersection for that one is right here where this tangent line goes across. So the tangent's only touching one place. This one is going through like that. That one is touching in, I've got a point here, and that took care of this for the 65-degree arc. And I got the point right here, which takes care of this bigger arc. I need to figure out what that measurement is. I know that down here I've got 120 degrees. Right there I got 65. All the way around the circle is 360. So I'm going to subtract the 120. And I'm going to subtract the 65. And that gives me 175 degrees for this arc right there. Okay. And so now what I can do with that is I know that x, that angle, is going to be, you take the bigger of the two arcs and subtract the smaller one from it, and then divide that by 2. Okay, and that's 110, and x equals 55 degrees. Okay, so this one, because it's outside, I'm using differences. On the other two, the first two, the point where the lines intersected, the vertex that I was dealing with was inside the circle, and so those were ones where I added the two arcs together. And let's look at the next one. Number 4. Okay, this one is much like the last one, except I know the angle right here. I know this arc is 20, and I'm looking for this arc out here. That's X. Okay, so on this one, I'm going to say 35. That angle formed at that outside vertex is equal to, X is going to be the bigger one, so I have X minus 20 divided by 2. To solve that, I'm going to multiply both sides by 2. That gives me 70 equals X minus 20. I'm going to add 20 to both sides. And I end up with 90 degrees for that arc on the far side of the circle from the 35. Okay, next one. I've got an X. And I've got both lines are tangents, okay, that I'm looking for, and I only have the 240 degrees given to me here. Okay, looking for X. Vertex is outside the circle. When I have tangents like that, there's just one point where it intersects here, one point where it intersects here. Okay, this is 240, which means that this right here, the smaller arc, is going to be 360 minus 240, which gives us 120. Okay, so this is 120 degrees. And so we'll solve this. I'm just going to do X equals 240 minus 120 divided by 2. 240 minus 120 is 120. Divide that by 2 and I get X equals 60 degrees. Okay, the last one, number 6. Similar, I do have a tangent. On the top, I've got a line that comes through down here, intersects right here and here. All right, I've also got some other things going on inside. Here's how I'm going to start. Okay, this is where I'll start. I'll start right here. Okay, and when I start there, I'm going to look at the Y. Okay, I'm going to look at this Y. And that's an inscribed angle. Okay, this point where it meets is on the circle. And that tells me that this arc from here to here, that 180 is double that Y. Or in other words, Y is half of 180. In other words, Y equals 90 degrees. Okay, well, now that I know that Y is equal to 90, well, I can figure out what Z is, because inside that triangle that's in there, that's 180 degrees. Okay, so I'm going to take 180 degrees. Z is going to equal 180 minus the 46 minus the 90 that I just figured out that Y is. And so Z is going to equal 44 degrees. Okay, from that Z, which is also an inscribed circle because it's right there on the, I'll use this, it's right there on the circle. Okay, and so when I look at the intercepted arc, it runs from here to here, which is the inner arc that I need to be able to find X. Okay, and hang on just a second. And I don't have that, right? I got Z. I don't know. I mean, I did find Z. That's 44. Okay. And so with that 44, I can take that 44, and because this is an inscribed circle, that means this is going to be double that, 44 times 2, and I get 88 degrees right there. Okay. Now, another way I could have done that, I could have used this 180 that goes all the way around out here. I could have used the 46 to figure out this one, and then I could have subtracted the 180, and that 46 would have made this 92. I could have subtracted the 180 and the 92 from 360, and that also would have given me the 88 up there. Okay, so another way of getting that. All right, bottom line, I'm at that point now where I can solve for x. All right, and now I'm going to finish off. X is going to equal, I take the 180, it's right here, minus the 88, that arc, divide that by 2. All right, and 180 minus 88, that's like 92, divided by 2, and it gives me an x value of 46 degrees. Okay, and in this particular one, I was trying to find x, y, and z. Here's my x, there's z, and there's y. Okay, and that's it for today. That was kind of a fun one. Put together pieces of inscribed angles from the previous lesson and the things we learned today with that exterior point and then the lines intersecting with the circle, that we were able to kind of put all that together and come up with a solution on those. Tomorrow we're going to continue on with this particular lesson, but focusing in on the lines that are inside there as opposed to the angle measurements. But for today, we're done. Have a great one.